industry. We believe in this time that we have put together a series of composites which will perhaps form a breakthrough for the next generation of the industry. It's very difficult, you will appreciate now, with the products in the industry being so refined, to provide new answers to the old existing problems of condensation, thermal productivities, dB reduction and longevity. So although we will be showing you new products, polymers in fact, to produce houses, we will in fact be really showing you the endeavours that we have made to break through in the construction times. When one talks about factory manufactured housing, one is faced with the repeat product, all the houses looking alike and being very stereotyped. What we've endeavoured to do is to produce a library of some 13 panels from which we can produce a wide variety of houses. And our aim has been to say that at no time is the client left with a repetitive order. So let's move through the construction from the ground up. We formed a polymonoslab. This is a block which is full of insulation and has a totally impervious member below it, so that it's able to go directly to the ground or onto a post and beam construction depending on the gradients you're working to. The top wearing surface is a chipboard, and we have around the outside or perimeter of the panel a nub which is prepared to receive a wall or wall panel. So having formed the platform for our house with our slab, we come to the wall panels. In this case we've developed a series of wall panels, a library as we choose to call them, 13 in number, which appear to be giving us all the architectural configurations that are generally accepted in Western housing. Naturally, we had to incorporate within these panels the thermal values, the dB reduction, fire resistivity. Everything that exists we had to exceed, otherwise there was no point in progressing. We believe we've done that, and independent testing by many authorities have already proven this to be a point. The actual erection of the walls is very rational, having simplified the matter to a basic bolt configuration. The wall is offered to the floor and fastened by galvanized steel bolts. It's a very simple, straightforward process and should be done at the rate of 1 linear foot of house construction a minute, like this. The walls are provided in the factory with ducting at the bottom end of the panel and at the top of the panel, and then at 2-foot centres, which will receive all services, wet services, telecommunications, electricity or whatever. So we have made that provision for an easy looming of the house after construction. So we have our wall and floor sections built to the incorporated wall plate, and here we introduce the gable, factory manufactured and located as the wall is to the floor by galvanized steel bolts. So now we come to another major member of our family of panels. This is sky sheet, the means of closing the house. It's simply lifted into place over the wall plate and over the ridge and gable section. This is the roofing material which we have named sky sheet. It has enormous advantages, not least of which is its span. It's made in slabs, a monoslab which is 4 feet wide and up to 32 feet long, and doesn't require traditional trusses to support it. No interspersed beams. It can in fact provide clear open spaces and the benefits of cathedral ceilings without the usual imposed extra costs. We're talking about our values of 8.860. We're talking about cyclonic loadings with great safety. We're talking about impact resistance, and we're talking about marvellous dB reductions. The roof is very easy to fix, 1 man on the wall plate, 1 man on the ridge beam, and can be slotted together. The edges of the roof are profiled so that we have a totally waterproof joint, and 2 of these panels, side by side, filled with water, have maintained that water level for 84 days on testing, under pressure, with no penetration whatsoever. A recent test that we conducted with a traditional and newly to the market clay-baked tile, on submerging it in water, it absorbed 8% of its body weight overnight. 84 days with this product on test, no water absorption whatsoever. It is a totally waterproof roof. Obviously, we've carried out every conceivable form of testing. This product has been tested under the DLTX single carbon arc weatherometer to the equivalent of 1700 years. And we've used the polymers here for the construction of motor car bodies and components, and for yachts which have been highly competitive and separately have brought great pride to our organisation. You'll see that the roofs are made to almost any existing known profile. And as you can see, the panels as they're now coming together, we're ending up with a very traditionally aspected corner of the house form. I believe you'll agree that we have an aesthetically acceptable form of house construction. We've got a floor, we've got a wall, we've got wall plate, and connected to it a roof, which is traditional in its aspecting. So now we've got to add the accessories to complete the picture. The next part that we add from our family is that of a soffit, fascia board, and rainwater goods. And as you can see, that is a clip-in, locked-together component. And finally, we have the barge board. I've had 25 years, 30 years now in the development of housing technology and many, many systems. This one is almost foolproof. It's traditionally and aesthetically acceptable, and yet it's technically in advance of anything that I know of in the world today. We have the practical reality. This is the house that can be built from the components described in our previous conversation. You can see that it looks just like any other house. I choose to call it the time bomb house. Time bomb because it can be built very quickly. A couple of guys working together can build this house comfortably in a week, ready for occupation. Using the components already illustrated, simple bolt-together connections, this house can be ready for occupancy quite comfortably at the rate of a linear foot a minute.
It's called the Australian dream, but finding an affordable home is not just an Australian problem. There are millions of homeless people in the world, and so far science and technology have offered little in the way of solutions.
Hello.
Hello, Gail. How are you?
Good, thank you.
Bill Dodds has a dream too. He thinks he's found a way of giving people homes that are cheap, structurally sound, and energy efficient. His secret? Plastic. There's not one bit of steel or timber needed to build this house. The whole thing can be made of plastic. This particular house is finished with plasterboard and timber as a concession to conventional building tastes, but the shell, walls, floor and roof, everything else is plastic. But not just any kind of plastic. Bill and his son Simon have their own secret formula. Bill won't tell us what's in it, but according to his successful building accreditation applications, Bill's houses are more durable and less toxic in the event of a house fire than timber houses, and resistant to earthquakes, cyclones and termites. In fact, Bill's houses exceed all Australian building standards. It's a house that fits like Lego with the other pieces. The brick cladding is purely cosmetic. And the cost? For a two-bedroom house, complete with stove, dishwasher, plumbing and paint, a mere $31,000.
They're as cheap as anything could possibly be built. The saving is in building them rather than manufacturing them in the factory. Basically, the material content's the same as any other house, thereabouts. But there is a saving of about 80% in the construction time. In other words, we're eliminating the need for a tradesman on site.
And that's one of Bill's difficulties. 3 people can put a house together in a week. A forklift would come in handy, but basically you don't need any particular skill or trade apart from getting a plumber and an electrician in for half a day. But any technology that threatens jobs is going to have a hard time competing on its merits. And it's not just jobs that are threatened. The building industry in general has an enormous financial investment in existing technology. But greater than these obstacles is the public's poor perception of plastic itself. Plastic has always been something of a dirty word. It suggests second best, imitation, not the real thing. And now that plastic is widely seen to be a menace to the environment, you'd think that only an idiot would try to promote its use for something like housing. But think again. One of the greatest contributors to the greenhouse effect is the burning of fuels to create energy. Plastics are energy efficient. The plastic house uses less energy than conventional houses at every stage of production. And because of the air trapped in its walls, the plastic house requires less energy for winter heating. The plastic house is 10 times more energy efficient than the average Australian home. This small 2.5 kilowatt heater heats the entire house. That's an 85 to 90% saving in electricity use every year. Another contributor to the greenhouse effect is the logging of trees. Housing construction is the biggest consumer of timber, so plastic houses mean less logging. The real problem with plastic is that it's so hard to dispose of. But a house is not what you would call a disposable item. It's food containers, wrappers and the like that become pollution problems. And it's not inconceivable that houses could be made from recycled plastic, in which case they'd actually be helping to clean up the planet while protecting precious forests. It's 40 years since Bill Dodds perfected the technique of making houses out of plastic. Today, he's more certain than ever that it's the way to house the world. But it hasn't happened. His story is a perfect illustration of the difficulties you face when you try to change the way people think and when you're up against powerful vested interests.
An innovative set of building panels and components developed by Toro Consulting Group, an Australian government-approved research and development organisation designed to provide new answers to age-old problems associated with the building industry. These components address such things as condensation, insulation, sound reduction, lifespan, speed of erection, and therefore lower cost of construction. These answers have been provided by the use of polymers and materials already tested and proven in familiar applications such as automobile bodies and components and boat construction. The system had to not only meet but exceed a wide range of existing building regulations, as well as incorporate within its form insulation values, sound reduction, fire resistance properties, termite proofing, ultraviolet light resistance, cyclone resistance, and of course aesthetic acceptability. The particular house type that we will demonstrate here has been developed as a low-cost home. The inventor of the product explains.
We of course test all our products, but this house has been hyper-tested. It's suffered every sort of atmospheric trauma. We've put it through testing which shows that it's proof against earthquake and cyclone and monsoon and typhoon. It's also been shown to attract none of the normal borers attracted by traditional building materials. We know that it's termite proof, and we know that it's going to stand out there against the white ants that ravage it in any parts of the world. We call this house Balmondo, the World House, specifically designed to be containerable and readily transported to any part of the world where the demand may be. You'll see the vehicles arriving with the house panels on them. These would normally be arriving direct from a consignment of containers. You'll see from the two vehicles involved here that with all the panels together, you would get at least 2 of this size house into a 40-foot container. This particular house we are looking at was produced for American conditions, where it was indicated there would be requiring a concrete slab on site. Here and there you'll see these metals arising from the slab. We would normally anticipate that the reinforcing in the slab would be bent to a vertical section, ready to receive the panels that are passed over them. If the building standards can't accommodate a concrete slab, there would be rods which had been driven into the ground to a depth depending on the wind loadings that are likely to be anticipated in the area. You will see that we have manufactured all the panels of a size that can be carried easily by 2 men. This is one of the advantages of this construction. We have designed it so as to be efficiently erected by non-skilled labour without the need for costly mechanical assistances. So we would offer a wall over the metal section to the floor slab. Lift it over those sections, let it drop to, and then compress the joints, offering one to the other. It's a very simple mechanical compression fit. An impact, as David has just done there, will make the wall a permanent closed drain joint section. We would offer the wall over the metal sections, let it drop. When it drops into place, usually a good pressure on the top will close the wall and make it into a permanent construction. As each panel is added to the structure, so it gains strength, panel by panel, wall by wall. You would naturally be required to prop the walls if it was gusty, as it was on this particular day, but the requirements for propping decreases as the house develops as a box. You can see it's quite a simple slide-together connection. The next step is to produce a mixture of slurry to put into the wall to enhance its strength, thermal values and dB reduction. We have a prescribed optimum fill, but this may vary from country to country, and if you are in an area where even the cost of the cement is beyond the budget, we have to consider that it may simply be a silica fill, sand or soil, or whatever is available locally. We would like the very minimum to be an admixture of soil, aggregate gravel, with a 10% minimum cement content. The slurry is offered into a simple hopper which is placed on top of the wall. The walls are produced as an open chord sandwich, so the slurry is poured in, and again, without the requirement of any mechanical assistances, you would put it through a simple trough hopper and allow it to slide down and into the panel. Here we are locating another panel. The ease and speed of building is quite remarkable, and you can see that these 2 young men are rapidly putting the house together. To assist the sliding together of the roof components, we would suggest simply wiping the edges with a light lubricant. This will ease the sliding of the components together. They're made in panels 4 feet wide and will spread from the ridge beam to the wall plate. Very simply, when you've located the roof panels to the wall plate, you would stand on it, and that will close the connection, and it's permanent. The roof has remarkable strength in spite of the fact that it is an open span and doesn't have any form of truss or roof bearer. This is the ridge tile. You can see it's a very open product which allows the air to pass through the voids in the roof and to rise by natural convection to the ridge where it dissipates. This allows us to have something for nothing benefit. In other words, drawing the cooler air from the eaves level, it passes across the roof by convection and emits through the roof tile. Within a couple of hours of arriving on site, it's entirely possible to have the house weatherproof and ready for decoration and fitting out. We've indicated that electrical fittings can be put into and through the wall prior to the pouring of the slurry, and the house has grown, almost it seems as nature intended, quickly, efficiently and without problem.
And there you have it, a radical innovation in the building industry.